Well, we have another alternating series. So let's use the alternating series test to determine whether I converge or diverge. So part one, to see if the a sub n, that is to say, the portion of the nth term without the sign change, is the nth term of an underlying decreasing sequence, I will yet again compare a sub n to a sub n plus 1. Both of these are the following. But yet again, just as with the alternating harmonic series, notice how these two numerators are equal to each other. But given that this denominator is larger than that one, this fraction has to be strictly smaller than that one for all natural numbers n. To check the second criteria with the alternating series test, well, just by observation, isn't it pretty darn clear that as n increases without bound, I hope I said that correctly, as n increases without bound, then this particular a sub n is equal to 0. Therefore, by the alternating series test, notice how nice it was in part one. I was able to use basic 9th grade algebra to determine that relationship, only because these two numerators were equal to each other. Gosh, I hope I have that number correctly. I don't really remember. So everybody, check this out. Another alternating series. And to see if the underlying sequence without the sign change is a decreasing sequence, I need to compare these two. So just as with the example we just finished, let's analyze the relationship between these two. Now, unfortunately, neither numerators or denominators are equal to each other, but if we treat these denominators equal, since this numerator is larger than that one, the fraction on the right is larger. If the numerators are equal to each other, given that this denominator is larger than that one, this fraction on the right is less than the one on the left. So I don't think I can use some basic 9th grade algebra to determine if the underlying sequence involving a sub n is indeed decreasing or otherwise. So I give up, claim defeat, and let me proclaim that I got a whole new function f, whose output is this, meaning the output agrees with the nth term of the sequence of a sub n's for natural numbers n. And to see if this function is decreasing, at least for values of x that big, let's differentiate. If this derivative is negative for all such values of x there on up, then I know I've got an a sub n sequence that's decreasing. Now, if x is e, which is less than 3, this is 1, the numerator is 0. And for any value of x larger than e, like all those, this certainly is negative, divided by something that's always positive, and therefore f prime of x on a sign graph has this quality. That being the case, these two are related as such. Now, that being the case, part two, if you and I take a peek at the limit of my a sub n. Okay, everybody, here too, maybe we're a little bit stuck. Given that I've got the ratio of two functions in n, let's go ahead, yet again, just like with part one, rewrite this in terms of a continuous variable, because at least now I could use L'Hopital's rule. Therefore, again, a slightly more sophisticated example where I just didn't use that straightforward ninth grade algebra to conclude that this being the nth term of a sequence, that sequence decreases. So as I'm erasing, can you take a peek at what a sub n looks like? It's nothing more than the inverse tangent of n. Treating that as the nth term of a sequence, let's see if the sequence is decreasing. But of course, you're so familiar with the inverse tangent function, you know it's not decreasing, it's increasing. So the first criteria, as well as the second criteria for the alternating series test, are not being met. But that doesn't mean the alternating series test tells me anything about the series. Because both of those conditions are not met, it simply means that the alternating series is inconclusive. But that's okay, we got a way out of the trap. After all, so not using the alternating series test. Notice how the inverse tangent of n goes to this as an increase up down. Therefore, the limit with that thing going towards pi halves but alternating with every other term is popping back and forth to positive, negative, getting closer and closer to the extremes of pi halves and negative pi halves. Therefore, the limit of the nth term of my series, albeit alternating, does not exist. Doesn't that mean then the following? That is happiness, not factorial.